Hello everybody, welcome to the next tutorial. Uh, so here we are going to discuss about a real world example I'll give you and then we'll try to find it out the root cause. So I hope you have seen the first tutorial to have some basic understanding about the thread dumps, what things we have to look at. So yep, so let's get started. So I will mm, bring up this TDA thread dump analysis tool, which is again open source tool I'm using. So as already giving you a real world example, so I don't have to create a thread dump manually. So I will use some existing thread dump which was created during one of our production issues, which were a couple of weeks ago. So yep, so this is a real world example. So first I'll open this thread dump and let's see what is there inside this thread dump. Yeah. So in this thread dump here we see the different threads. Some threads are JVM threads, some threads are CPU thread, and some also this kind of threads which you see here, New Relic. It's our APM monitoring tool, application monitoring tool, which is also running as a Java native library to monitor our system. So these are the thread which is run by New Relic, and there are some threads which is, for example, these are the our application specific thread which is running. So here we see there are different state here. So I hope you are now clear what is wait on condition and object wait, and similarly what is runnable state and all this thing, and what is also waiting for entry. So if you do not know, again I can bring this thing here. So wait for monitors, it means just for a recap, it means to wait to lock an object since some other thread may be holding the lock, uh, and it is happening when you are using synchronized block. And waiting on conditions means it is waiting for some condition, like a reiterant lock, when it is waiting for some period of time and then it will come back to the it will release the lock. Wait- so this is some wait for monitor and then waiting on condition. So here this is waiting parking for wait. So here also we see that waiting for monitor, and this is blocked, so you do not have to worry about every thread that is blocked. So it now for the timing it is blocked and you're waiting for this lock, and after some time it may again release this blocked. It can release the block, and at the time it will not no longer be valid. So there are one thing we have to understand, that every blocked uh, a thread is not causing the problem. So there, first thing first, we have to look at these threads which are in runnable state, and then that can give us the clue. This that runnable thread while it is running, it has acquired some lock, and then that lock was never released, and because of that some other thread is also blocked. So for that we have to find it out always, the runnable state first. So here it's absolutely fine to have a blocked state here. Similarly, we can see different kind of block waiting on conditions, so nothing to worry about it here also. So here there are many health check also, some kind of logs are being used here. So now let's see what is there on threads for monitor. So these threads are monitor. It's for waiting for entry, and these are you can just ignore. These are doesn't cause any kind of a problem till now. So we have to look for waiting for entry which is blocked for a long time. So when it comes to block, so if it is only one or two thread is blocked, so that's absolutely fine. But when it is block thread, it's increasing uh, one by one, then it uh, creates then we have to be worried about. So here it's absolutely fine. So if I click on this object to lock here, then it directly comes back here and it says the object to monitor. So here it's only one thread is waiting and one thread is locked. So it's absolutely fine. So we don't have to worry about it. So, and now again comes back to here. Now here we see that there are so many waiting for entry. There are so many threads which is waiting for entry. Now we have to understand and we have to be more careful about this kind of thread. Yeah. So now here, if we look at everything here, so it is pointing to, if you notice here, it is waiting to lock this object. Just have a um, closer look at the last three digit. It is 440. So if I go back, see the every thread here, it is always pointing to 440, and everything is waiting for entry. So there are so many threads which is actually waiting for entry. So now if I click on this one, waiting to lock, yeah, so now here you see it is 39 threads is waiting. Yep. So everything it has logged and then object waits on monitor. So this is where our application is stuck. So why it is happening like that? So as I said, if you remember that when it comes to blocked state, so we have to find it out first. What is the runnable uh, thread that has first acquired the lock and why it is causing that? So block state, it's fine, but first we have to see the thread which is runnable state and acquire this lock. Okay, so for here we do not see any other entries here. So let's come back to threads sleeping on monitor. Here it is all waiting on condition. So which is absolutely fine here. Nothing to worry about here. So here also there are some threads. It's also you can see this URL here product. This is kind of a URL. Yeah, which is while executing this HTTP request, then it some of the threads went into parking for wait. And when we came here, it is also, if you have, you can notice here, this is the URL which is trying to get some information from our backend server, and that's the reason it is waiting for entry. So still now which we are not sure that which is the thread which is a runnable state. So this thing here, it does not say anything much about which is the runnable state. So here also we can see some other components here, other threads as well. It is also logged by blocked, and also it is waiting for the to acquire the lock. So this is also not in runnable state. So that means we have to look into the another thread dump which we created. So now I will open this thing. Okay, so let's see what is there inside of this file. So here also it will be the pretty same. Wait on condition, what are the threads are um, waiting for monitor entry. So yep, so these are all fine here. So here also we see here this is also blocked. Okay, so but our point of interest is which is in runnable state. So here now it is, you can see here this is also runnable state. So let's see what is happening in this case. Okay, so it is runnable state, but here it has logged this object. So here we see it's logged, and you may ask to yourself that why it has logged to this particular object, right? So if you remember that the lock one can happen when I'm using some synchronized kind of block the code which is synchronized. So if we look at, we'll come to this particular class a little bit later. So before that, what I wanted to tell you that in the we have to do the bottom to up approach here. So from bottom we can see all is fine, all is fine. Only thing is there, it is it has logged, but you don't have to worry about it. And why? It is just a normal operation how it is happening. So and then it is going up, and then it is stuck, it is on segment here. So that is fine. Yep. So I would not say it is stuck here, but it is just in running state. So because it does not have any object which is saying that it has stuck here. So now let's come back to, let's see the threads waiting for conditions. Yep. So Now let's see what is happening here. Waiting for entry, waiting for monitor entry. So here also it is says blocked, and here also it says blocked. It all, and if you notice here in the first thread also it was pointing to the same I has same object address which is ends with 440. So all things pointing to the same here waiting for monitor entry which is blocked. Till now we are not sure that which was the first thread which was trying to acquire the lock that is in runnable state. So let's see what is happening here. So still it is looks fine for me. Still, so all things are waiting on conditions here, so it is fine. So now let's go back to this one, monitors. Yeah, in monitors here, we scroll down. Yep. So what it is happening here? So here you see it is saying that 9 thread is waiting and event dispatcher is the thread which is blocked, right? So now if I click on this here, now you see it is in runnable state. Okay, so this thread is runnable state, and after that what is happening here? So this all these all these threads are actually blocked, and reason why, because when it first came to this runnable state, then if we go by the bottom to up approach, so as we see here, so first it acquired the lock here of this particular object, and then it is acquired the lock here, and after that it is also trying to acquire the lock on event dispatcher. Okay, and then it is stuck here in Java util has new node. So this is the point where we can uh, have our more uh, attention here, that why it is stuck here. And here after that what we can see here, all the thread, right? So all the threads which trying to acquire this lock on event dispatcher is waiting, it goes on to waiting for to lock state. So similarly it is also happening here, so blocked. So what happened at the first, so when we executed this URL, this HTTP request, then first acquired the lock and it comes to this event dispatcher. This is the locked object, and all other thread is waiting to acquire the lock, but this lock was never released. This lock was never released, and that is the reason all other thread which is waiting on monitor condition has gone on into block state. So that is the reason why it is all other thread which we saw in the another dump file everywhere. So it is on waiting on monitor condition. It's stuck because of this thread. So now we know this what is causing the issue. So this is the event dispatcher is causing the issue. So if you are wondering that what is event dispatcher is doing, so for that let's see what is doing here. Okay, so event dispatcher. So I have just this event dispatcher is an open source open source Java file. You can it is part of Sling community, OSGI community. Sorry about that. So OSGI service. So this is event dispatcher is kind of a mechanism which actually keeps the track of different messaging system. So if you know the little bit details about publisher and subscriber mechanism, so it's in OSGI also there is something called publish subscriber mechanism, but it's different from actual publish subscriber mechanism. So in OSGI there is something called event whiteboard pattern. So how whiteboard pattern is different from the a normal publisher subscriber module mechanism. So for that I have tried to give you an example here. So in whiteboard pattern what happens is that there are a channel basically where event publisher and event consumer is sending the request, sending the event to both these channels. So if you look at it, right, so it is both working on the same kind of sending event to both channel. Event publisher is sending the event, and event consumer is receiving the event, but it is take is, in another word, it is taking the event from the channel. So which has this event publisher has sent the event to this channel, and event consumer is actually taking this event from this channel. And why is it different from publisher subscriber mechanism? In publisher subscriber mechanism, the publisher is actually tied to the subscriber, right, and vice versa. So, but in OSGI world, this is not an ideal case, because in OSGI each and every bundle is actually sending an event, and how this actually every bundles is actually communicate to each other by some event. Okay, so this event, when it there are so many OSGI events, it has to the publisher and subscriber mechanism become really a nightmare. So you cannot basically keep a track which publisher has which publisher and which subscriber are tied to each other. So in that case, whiteboard pattern comes into picture. So for that whiteboard in here, so it is sending the event here and also receiving the event here. So basically we have a common channel, and both the channel is consuming this same kind of a queue. And using that, it is really easy to track which kind of event is happening. So if I can give you some example, like when an OSGI bundle is started, then also it starts it gives an initiates an event. Also when it communicates to one bundle to another, then also it's another system event. So this kind of event is happening in the parallel. So if you are familiar with OSGI framework, then you will try to correlate what I'm talking about. So in OSGI we have a start and stop. So all these things are basically an event, and all the other bundles has to listen to this event. So this is where this event dispatcher comes into picture. So event dispatcher is actually sending this signal to other listeners basically, and that is where, so when we are doing this load testing in our situation, so many requests were initiated in the parallel, and at the time this locked it's tried to lock this event dispatcher, but it was never released because there are so many events were going in parallel. So and because of that, it has logged here. So here, so I hope it is clear to you now. So why it is stuck here, and how do we find it out the different how do you find it out the actual root cause why it is stuck here. So just to recap again, that first we have to see the runnable thread which has locked this event dispatcher, not the blocked one. So blocked comes to the later state, right? So if you look at the thread lifecycle, first it goes to runnable, then other state comes subsequently. So this is how it is we have find it out this why it is stuck here. So now if we want to also compare the another easy way to compare with this kind of problem is actually have because of this thread or not. So you can also do one thing, that you take the heap dump or thread dump when there is no much processing is happening at the server level. So for example, when it is idle or something very low load test is happening, so when server is not having much load, so at the time also we can take the thread dump, and also we can compare basically to see whether what is happening at that time. So I have already taken that one. So for here I have thread dumps, and here I have a good threads. Yeah, so we see without issue. So here if we look at this without issue thing, so let me come back to here directly. So here we see there none of the threads are in stuck state. So all these threads, none of the threads are waiting. There are one thread is waiting and something is waiting, but it is absolutely fine. So it is not like multiple threads are in waiting state, and this is causing block. So by comparing this good thread dumps versus bad thread dumps, you can also understand that what is the problem, so which can gives you the more insight of it. So yep, that's all from this video. So I hope you learned something, and if you have some further questions, so please let me know in the comment. Thank you. Have a nice day. Bye bye.